Hello, let's continue our Sudoku adventure with Dark Secrets by Palfly Kampling. This continues our Killer Cage theme week. We're getting to some creative uses of killer cages here. Yesterday we had some coloring stuff. And today we have unique killer cages. Let's go over the rules. So we have normal 6x6 Sudoku rules. So in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have killer cages in the grid. These are these cells surrounded by dotted lines. The way these work is they deal with the sum of the digits. Normally we'd have a clue in the top left that tells us what the sum of the digits are in the cage. Notice that these are just single digits, so the sum is the one digit that goes in it. But in this case, we have to figure out the sum. And part of the way we do that, or actually the only way we do that, is all of the sums of all these killer cages are unique. So let's say this was 2, 4. That would add to 6. That would mean that none of these other cages can add to 6. Not a single one of them. So what we can do is we can take this 6 here and we can just mark it as used. And that's just for bookkeeping. You don't have to do that. But that's what it's there for. Additionally, we do have crop key dots in the grid. White dots separate consecutive digits. So if this was a 2, this could be a 1 or a 3. So it's consecutive. That DT2 does not mean this digit is a 3. Anytime you put a 3 in any corner, it'll DT2 at you. All right. We also have black dots in the grid. They have a 1 to 2 ratio, meaning 1 is exactly double the other. So if this was a 2, this could be a 1 because 2 is double 1, or it could be a 4 because 4 is double 2. So the order doesn't matter. What matters is one of them is exactly double the other. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. These are single digits with a 1 to 2 ratio. How many? Okay, I'm going to count how many cages we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have 10 cages. Now, how many total sums can we have? Well, we only have 1 and 2 cell cages. 1 cell cages can be 1 through 6, and 2 cell cages, thinking about it, the smallest 2 digits you can put in a 2 cell cage are 1 and 2, which makes them add to 3, and the biggest 2 you can do are 5 and 6, which adds to 11. So we can basically add from 1 through 11 in total in this puzzle, but we have only 10 cages. So one of these digits will be omitted. So we can't say we must have 1 or 2. Well, we can't say we have 1, 2. What do I say? We can't say we have both 1 and 2. That's what I'm trying to say. If we needed both 1 and 2, then that would mean they'd have to end up in these cages because the minimum is 3 for a cage. But we cannot say that. We know that this cage is odd. I'm actually going to color it orange to show that the sum of these 2 digits will be odd, because 2 consecutive digits always add to an odd number. This cage will always add to an even sum, because if you, well, no, that's not true. That's not true at all. The thing I was thinking of is a black dot always contains at least 1 even digit, because one of them is double the other. But that doesn't mean the sum is even. We know that these 2 sums, one of them is even. None of that's particularly insightful, is it? This is also an odd sum. How many odd sums do we have for a 2 cell cage? There are 5. 1, 2, 3, 4, 5. Yeah, there are 5 possible odd sums. So what else can we do here? We know the sum of this box. Maybe that's our start. Why do we know the sum of the box? We know the sum of every box in every row and every column. It's 21, because they have the digits 1 to 6 once each. So the digits 1 through 6 once each. If you add them up, you get 21. So, what does that tell us? The total is 21. So 3 digits that add to 21. Okay, here's the first little deduction we can make, which is actually not even related to that, which is 5s cannot go on black dots. If you put a 5 on a black dot, what are you putting next to it? You can't double it to 10. That's too big. You can't have it to 2.5. That's not an even digit or a whole number. So the 5 ends up here because it can't be on a black dot. So this cage contains a 5 for sure. You know, I don't think it even matters that these 3 add to 21 because they're going to no matter what. So how do we... This could be 1, 2, which adds to 3. It could be 2, 4, which adds to 6, or it could be 3, 6 adding to 9. Okay. 2 black dots that don't share any digits. One of them has to be a 3, 6. Because the options are, let me just write out our options. They're 1, 2, 2, 4, or 3, 6. Those are the only 3 black dot pairs we can put across a black dot in a 6x6. And notice 2 of them use the 2. So one of these will use up the 2, meaning the other one can't have a 2, meaning it'll be 3, 6. Meaning this uses up the 3 and the 6 here, or this is a 3, 6 pair, making it add to 9. I don't know what to do with that. Interesting. Really don't know what to do with that. And then the other one will be 1, 2 adding to 3, or 2, 4 adding to 6. All I have are these pointing 5s, so that's all I figured out. There's clearly something I'm missing. This is not a 5. Okay. This is probably the most important initial deduction, which I might have been able to make earlier, which is, look, all of our single cells... is this even... that's not even a good deduction. Well, what I was going to deduce is none of these are 5. And I thought that meant we couldn't have a 5 sum, but of course we can have a 5 sum. We can do like a 2, 3 somewhere. Or a 1, 4 in a... So that isn't it. Darn it. I thought I had something. We know none of these are 5, though. This isn't 5. These aren't 5. I don't really know what to do with that. So these single-digit sums are non-5. So 3 digits from these are used by the single digits. I just don't see how that's... Okay, let's think about it this way. We could omit a 1 or a 2, but we can't omit both 1 and 2. That would only leave 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would only leave 9 sums. So one of these is a 1 or a 2. If any of these are a 1, it also puts a 2 next to it. So the only way to avoid using a 1 would be to put a 2 in one of these next to a 4. That would use up the 4. So the 2 is always used by one of these single digits. I think that's true. Yeah, okay, so I don't know. I'm still thinking through this. Let's think through this out loud. So we must use a 1 or a 2 in one of these pairs. We must use a 1 or a 2. Obviously, if we use a 1, we are using a 1. But if we use a 1, we're also using a 2. So the only way to omit using the 1 is to use a 2. So there's always a 2 involved in these cells. So if there's a 2 involved in these cells, somewhere in these 3 cells, there's a I guess these 4 cells, there's a 2. I think it's even saying in these 3 cells, there's a... No, because if I use the 1 here, this has to be a 2. And then I can omit the 2 from over here. So one of these 4 cells is a 2. I don't know what to do with that. Okay, let me think about it this way. If this was a 1-2 pair, how does that work out? That makes this a 3-6 pair. So we know one of these is 3-6. Okay, so well, I guess one deduction we can make is that this does not have 3 or 6 in it. And it doesn't have 2 in it. So 2, 3, and 6 are gone. So this is only 1, 4, 5. We know it contains a 5. So it adds to 6 or it adds to 9. It cannot add to 9 because the 3, 6... Well, oh no. If this was 3, 6, then this can't add to 9. I think that doesn't work. Okay. So if this is 3, 6, that uses up the 9. So this cannot add to 9. So it would have to be 1, 5, adding to 6. And then now what do we put in here? The last 2 digits are 2, 4, which also adds to 6. Wow, that's crazy. Okay. So this cannot be the 3, 6, meaning this is the 3, 6. Meaning this has to use a 2. Right. Now that this is 3, 6, that adds to 9. This has to be 1, 5. No, sorry, it doesn't add to 9. That uses up 3 and 6. So we can't do 1, 5 because 6 is used up. So this is 4, 5 adding to 9. And then the remaining 2 digits are 1, 2. Okay. So what's used up? The 3, the 9, and the 3. Oh, I know I have two adding to 3 right now. Oh gosh. Okay, I must have missed a case. Okay, so 5 is forced here. Let's think about these cases. We know that this is going to have the 1. So we know one of these is 3, 6, and one of these is from 1, 2, 4. Using the 2, which means the 1 or the 4 is left over, not in these cells. That's going to end up here. So this definitely, and because it has a 5, this definitely adds to 6 or 9. Now, we know that if this was 3, 6, this could not be 4, 5 adding to 9. So it would have to be 1, 5 adding to 6. But now this would be 2, 4. And I said that adds to 6, but this isn't a cage. So that's fine. This would use the 2 and the 4. So that's okay. Darn it. Yeah, I think I made the same mistake a bunch of times. Wow. Phew. So that does work. The other case is that the 3 and the 6 are down here. So now this can't add to 6. So this would be 4, 5 adding to 9. And then up here, we would have the 1, 2. And that doesn't work because one of these adds to 3. One of these is a 3, and then this also adds to 3. Right. Okay, so we can't do that. This is the 3, 6. This can't be 4, 5 now. And then this is 2, 4. So we know that the 2 and the 4 are used up by the bottom 2 here. Also, the 9 is used up by the 3, 6, and the 6 is used up by the 1, 5. Okay, finally got there. I don't know if it needed to be that hard. We know that there's a 2 and a 4 up here. And they can't both be across this white dot because the white dot doesn't let you do a 2, 4 pair across it. So this is definitely one of the 2, 4s. And so this is going to be, if we use the 2 on the white dot, it's going to be 1, 2, which is fine. It can't be 2, 4 because, sorry, it can't be 2, 3 because there's a 3 in the row already in this 3, 6 pair. If we use a 4, then it's going to be 4, 5 because again, we can't use the 3. Yeah, because this 1, 5 goes along with the 2, 4. I guess that would be an easier way to put it. Down here we need a 3 and a 6. Okay, how do we follow up on this? So this digit here is a 1, 3, or 5. It's definitely not a 5. We've gone over that. 1 would go with 2. 3 would go with 6. Okay. Now, do we need to worry about adding here? Yeah. If we were 4, 5, we'd add to 9, and that doesn't work. So this has to be 1, 2. So this actually adds to 3. 3 is used up. So this can't be a 3. This is 1 and 2. That uses up the 1. This makes that 2 and 1. I really didn't need to say this. I knew this was an odd. Anyway, that's 4, that's 5, that's 1. So down here we need the 3, 5, 6. Okay, we used up the 1, we used up the 3. Okay, I did mark those. Okay, we know 1 and 2 end up down here. In fact, the 1 ends up in this cage. We can't also put the 2 in it or it add to 3. So this 2 ends up placed here. And so this could be 1 plus 4 adding to 5. It can't be 1 plus 5. It could be 1 plus 6 adding to 7. Okay. So this is the... Oh, but this can't be 4. 4 isn't one of these two. Oops, not over there. And so these can't be 4. So this is 1, 6. That adds to 7. 7's used. And so these 3 digits are... Actually, first of all, let's place the 6. Now these 3 digits are the 3, 4, 5. That's not 4. We know this we know this has to be a 4 because this is 3 or 5. This is odd. You always have an odd and an even on a white dot, or if you prefer, the only digit that's consecutive with 3 or 5 that's left is the 4. However you want to think about it. It places the 4 and this 3, 5. Probably need to worry about sums here, but let's just put 3, 4, 5 across here first. Okay. This is a 3, 5 pair. The rest of this column is 1, 2. So we can't do 3, 1. And we can't... Oh, we could do 3, 2 adding to 5. The 3, 1 would add to 4. This was a 5. We couldn't do 5, 1 or 5, 2 because 6 and 7 are used. So this has to be 3 with a 2 adding to 5. Okay, so that's a 5, that's a 5, that's a 1. These are not 5s. I really don't need this orange, do I? Well, actually, we know this is an odd sum. There's only one odd sum left. So actually, that worked out. This has to be 5, 6. So that's a 6, that's a 5, adding to 11. Now all of our sums are even. This is 3, 4. That's place. 3, 4, 3, 6. Whole stack's done. All right. So up here we need 1, 5, 6. Down here we need 2, 3, 4. This cleans up. That's a 6. That's not a 2. All right. We know that we only have even sums left, and this is odd. 1 or 5 both are odd. So to make it even, we need another odd digit. It has to be the 3. That makes that 4 and 2. 3 does deet in the corner. That's a 3. It's 4 and 2. That's 6 and 3. 1 and 6. 5 and 1. So that's the 8. And then 4 and 5. And we're done. And the only sum we didn't have was the 10. All right. Once I figured out what was the break-in was pretty tough to think about, because there were a lot of different ways I was trying to think about this. But yeah, the way this box resolved was pretty surprising. Using the unique sum, forcing the 5 into here, knowing that we were going to use 3, 6 over here, and then one of the 1, 4s, left this as 4 and 4, 5. And then the case where this was 3, 6 didn't work out, which was really interesting. All right. Really neat idea, Palfly. Good execution as well. And I hope you enjoyed this. If you did, then why not leave a like, subscribe, and a kind comment below.